Okay, Trig, this is section 4.2. We're going to get through just a little bit of it today. Kind of like section 4.1, there's a lot in this that they kind of throw all at you at once. So it might take us a couple days to get through this, so I'll just kind of baby step through this. They're starting to get us introduced to the unit circles. So you guys will need to take out your pink sheet that's got this guy on it, and we're going to dive into learning what some of these numbers mean on the unit circle and how to like use the unit circle to do stuff. Okay, so take that out. We're going to use him. I'm going to talk about him here in a little bit. And I have a secretary over here who might be, making some noises. But anyway, yeah. What do you think? So as far as homework goes, here is the homework for this section. We won't get through the whole thing today, so you might be able to do up through like 16. Maybe a little bit further than that. I think 2, 4, 6, and 10. Hey. Shh. I think 2, 4, 6, and 10 are all like the vocabulary stuff. So like filling in the blank and that type of thing, which we usually don't have. So those are going to be a little bit easier, but then you might be able to do 16 and maybe 22 and 24. I have no idea. We'll see how far we get. So, all right, as far as evaluating the unit circle, we talked about in section 4.1 about putting a unit circle onto a coordinate plane. So you've got your X and Y axis, and then we're going to rotate angles around it. Okay, so the first side of my angle is going to start on the X axis there, and then I'm going to rotate my angle like this direction, right, counterclockwise, to make angles. So this might be like a 120-degree angle. I don't know, whatever. But now we're going to talk about like actual values if I make that into a triangle. So like, let's say I have this thing going on here and I have that angle. What we do is we make a triangle out of it and I connect him back to the x-axis, and then we put it, match it to a coordinate point. So what this is going to say is that in order to get from the origin to this point, I have to go negative 1/2, which means to the left 1/2, and I have to go up the square root of 3/2. That's how I get to that dot, which is 120 degrees or whatever they say that it is, right? So that's kind of how these little coordinates are on the unit circle. Like this dot right here is 1, 0. That's the coordinate point. I go over 1 and I go up 0. Because our radius we assume is 1 for the unit circle. It's just a 1 unit circle, okay? They have x squared plus y squared equals 1. This is the equation for a circle that's centered at 0, 0. I remember when we did equations of circles, it was like x minus h plus y minus k squared equals the radius squared. And this just means that our h and our k are 0 and our radius is 1. So that's what that information is, okay? So according to this, that's how all of that stuff is divvied out, okay? If we go over here, let's just talk about how a unit circle is broken down. Like, where do they get these little blue lines from, okay? So they don't do, obviously, every angle that there possibly ever is. They only do increments of 30s and 45s. So they do 30 degrees, then 60 degrees, then 90 degrees, 120, 150, 180, all the way around to 360. But then they also do increments of 45. So 45, 90 is also an increment of 45. It's an increment of 30 and 45. 135, 180, 225, 270, 315, all the way around. So increments of 30s and 45s, that's the special ones that they talk about going on here, okay? And again, these coordinate points, like this guy right here, is talking about this dot. If I try to go from the origin on a coordinate plane and go over to that dot, I would have to go over the square root of 3/2, that amount, and I would have to go up 1/2, okay? That's how that works to arrive at the 30-degree mark. Now, these coordinates are significant because maybe write this down at the top here. I know it's on your unit circle. On your unit circle on the top corner, if you look at that on your pink sheet, you have something that says x comma y is equal to cosine comma sine, okay? So the way that this unit circle works is that it's trying to help you, sister, goodness. It's trying to help you be able to do things without having to type everything into your calculator every single time, okay? So like, let's say I'm trying to find cosine of 30 degrees. I could type into my calculator cosine of 30, right? Like, you can do that. And it's going to give you a decimal, because that value is the x coordinate of what it is right here, the square root of 3 over 2. If you want to do sine of 30 degrees, you can type that into your calculator as well, but that value is going to be 1/2, right? Cosine is the x coordinate, sine is the y coordinate, and that's how that works, okay? So like, let's bump over here, and let's say I want to do, I don't know, 210 degrees. If I want to find cosine of 210, it's going to be this value. If I want to find sine of 210, it's going to be this value. So I can just read those off of the unit circle and not have to type them in every single time, okay? You can do this the same with radians. So let's say I want to find, I don't know, cosine of 5 pi over 3, which is 300 degrees. But let's say they give me 5 pi over 3. I want to find cosine of 5 pi over 3. I can type that into my calculator, except when I'm typing it in as 5 pi over 3 instead of 300 degrees, you have to be in radian form, okay? So I will show you tomorrow how to switch from degrees on your calculator to radians. It's under the mode button, okay? Some of you guys might be able to fiddle with it and figure it out, but you have to be in radians versus degrees. If you're going to evaluate degrees, you can be in degrees, but if you're going to evaluate in radians, you have to be in radians. The unit circle, the beauty of that is you don't have to convert between anything. If you just find it on the unit circle, you can find the cosine value and the sine value and then be done, okay? I think your unit circle that I have printed out also has the tangent values of each one, right? Like tangent of 60 degrees is like the square root of 3, or no, tangent of 30 degrees is maybe the square root of 3. I don't remember what it is. Anyway, but they are written off to the side over here on each increment, okay? So find that on your pink sheet, and you also have the tangent values as well. But that's kind of how to read this unit circle, okay? So let's bump back up here, and we've got this little circle going on right here, and they have these points matched, and I have bleeped out these guys because we're going to fill them in. So let's just get used to like writing the radian version, okay? So like here, we know that this is 0 degrees, but in radians, that would be 0 radians, okay? This guy right here, if I make him into an angle, that would be 45 degrees. He's half of a 90, and 45 degrees, well, we'll get back to that. Let's just do the angles. This guy would be 90 degrees, okay? This guy right here is exactly between 90 and 180, right? 180 would be this top guy. I don't know if you see these little blips that are going there. So he's referring to the 180 degree, okay? Right in between 90 and 180 is 135 degrees. If you add 45 to 90, you get 135. If you subtract 45 from 180, you get 135. So that's the 45 degree increment between those two, okay? So that's what those are. This guy right here, you can, I don't know, like here would be 225. These are also on your unit circle. 225, this is 270. 270 plus 45 is like 315, I think. Okay, so 315, or you can write him as negative 45 degrees because that would be like going down this direction. So both of those really mean the same thing. They're going to get you to the same place, but sometimes they'll write it as 315, sometimes they'll write it as negative 45, and those are the same place because those are coterminal angles, okay? I'm giving you lots of information, all right? So hopefully I'm explaining this well, all right? So let's talk about radians. We know 0 radians for 0 degrees. If we're going all the way around a circle, that's 2 pi. If we're going just halfway around to 180, that would be 1 pi. So pi radians is equivalent to 180. That's like when we convert from radians to degrees, we either go 180 over pi or pi over 180 because those are the same as each other, right? 180 is equal to pi. So then 90 would be half of that. It would be half of a pi, but they write it as pi over 2 rather than half of a pi. It's like pi divided by 2, okay? Then half of that would be at 45 degrees. That's going to be pi over 4. Oh, no. We ran out of snacks. Hold on. What? I know. I get angry when I have no snacks either. Yes, I do. Yes, I do. What? Yeah. What? There. It's all better. It's all better. Okay. So pi over 4 is half of pi over 2. That's what 45 degrees is. So these are all my radians. And then 135 is going to be 3 pi over 4. Okay, it's like 3/4 of a pie. If this is half of a pie, this is a fourth of a pie, half of a pie, 3/4 of a pie, a whole pie. So that's kind of how that works. So get your brain into thinking like in terms of radians, what those increments are. Okay, and at least remember which ones are the main ones, like a fourth, a half, 3/4, a whole. Okay, and then this would be, 5/4, 3/4, or three halves, or 1.5, 7 pi over 4, etc., right? Okay, so at least remember these top ones, and get used to thinking in terms of radians for the top. Okay, so there is that. All right, I just told you about the cosine comma sine thing. You guys have this at the top of your unit circle. So like 90 degrees, if I want to find cosine of 90 degrees, it is 0. If I want to find sine of 90 degrees, it is 1. Same thing with cosine of pi over 2, because pi over 2 is 90 degrees, it would be 0. Sine of pi over 2 is going to be 1, because that is the same thing as 90 degrees, okay? This is 180, so cosine is -1, sine is 0. Cosine of 270 is 0, sine is -1. Cosine of 360 is 1, cosine or sine of 360 is 0, etc., right? Like that's how it goes all the way around. Okay, so sine, I just said sine is the y-coordinate of wherever you're at on the unit circle. Cosine is the x-coordinate, okay? Now, there's a poster in my room that, I don't know, it's above, it's like in between the front TV and then like the north wall. And it says it's like tangent equals sine over cosine. Sine divided by cosine. So I have like a sink, a cask, and a tank or whatever. And then I have like Tanner or Costner, Siner, Costner, Tanner, whatever. Like I have the faces of Tanner up there on the wall. So that's Tanner Lemke. That was like a long time ago. You guys might not even know who that is. But that's tangent. Tangent is sine divided by cosine. So that's why they write it. Sine is the y-coordinate. Cosine is the x-coordinate. So when I put over here and I want to find like tangent of this guy, tangent of 180, I can figure out, I can do the y-coordinate, which is 0, divided by -1, right? 0 divided by -1 is 0. So I know the tangent of 180 is 0, because I just take the y-coordinate and I divide by the x-coordinate. Okay, I can do that for all of these, right? If you look at tangent on your unit circle of 90 degrees, let's talk about him. Tangent of 90 is the y-coordinate, which is 1, over the x-coordinate, which is 0. 1 divided by 0 is undefined. Okay, so that's how you interpret this unit circle. It's the sine divided by the cosine, or the y divided by the x, okay? And you can figure out all those tangent values going all the way around. I have them labeled on your unit circle, so you don't have to find them out yourself, but that is how those were all calculated, okay? Now, cosecant and sine go together, and then cosine and secant go together, okay? I don't know why the C's don't go together and the S's go together. That would be like, make sense to me, but that's not true. That's not the way that it works. So the S and the C go together, and the S and the C go together, and then tangent goes with cotangent. Here's the deal of how you figure those out. Whatever your sine value is, the cosecant value is that thing flipped, okay? Whatever your cosine value is, secant is that thing flipped. I know we did that in algebra 2 probably. Whatever your tangent value is, cotangent is that thing flipped. Or instead of the y over the x, it's the x over the y. So that's how that works. So like if I know that, I don't know, let's go down to your unit circle. If I know that sine of 30 degrees, sine of 30 is 1/2. I have that written up there right above. I don't know why I rewrote it. Sine of 30 is 1/2. Cosecant of 30 would be the flip of that, so 2 over 1, okay? Because those two things are what's called reciprocals. I take the reciprocal and I just flip it, okay? So that's how that works. We're going to do that in this first example. So we finally got to an example. Hey, there you go. Suppose that the real number t corresponds to this point on the unit circle. Okay, so that point on the unit circle, -2/3 is going to be this direction, and -5, square root of 5 over 3 is going to be this direction. Whoa, what did it just do? I don't know why I did a whole bunch of glitchy things. Okay, and -5, square root of 5 over 3 is going to be this direction. So we're talking about a point that exists, a point P in the third quadrant, whatever. Okay, this is the coordinate point for it, -2/3, comma, -5/3, the square root of 5 over 3. They just made that information up. Okay, they made that up for us. They want us to find the 6 trig functions that go along with this. So let's put them in order. We have sine of, let's call it t. we have cosine of t, we have tangent of t, we have cosecant of t, because that goes with sine. We have secant of t that goes with cosine, and then cotangent of t that goes with tangent. Okay, and they want us to find what all of those are. Okay. All right, now this is not a point that exists on the unit circle. They're just saying fill this in for this point that, you know, whatever. Okay. I mean, this is a point that would be on the unit circle, but it's not one of the specifically labeled ones. Like it might be this point right here that doesn't fall exactly at a nice place. Okay. So it lives there, but it doesn't have a nice coordinate point. What? Okay, hold on. We're ready for nap time now. Yes, we're ready for nap. Now you think it's funny. So sine, we just said the sine is the y coordinate. Okay, so this is going to be the value of sine. That was pretty easy. I just copy them down. Cosine is the x coordinate, -2/3. Okay, so that was not too bad. That was pretty easy. Okay, now let's do the opposites of those. So sine goes with cosecant. So all I do is I take this guy and I flip it. So he stays negative. I'm just going to keep the negative out in front, but he will be 3 over the square root of 5 now instead. Okay, we'll talk later about rationalizing that. Like I know that we don't like to have a square root in the bottom, but for now we're just going to leave him, and we'll fix him later. Okay, like not in this problem. I'm just going to have you do one thing at a time. Cosine is the same as secant, or the flip of secant, so he would be -3 over 2 is what he would be. Okay, tangent is taking the y value and dividing by the x value. So I'm going to do my work over here. I have negative square root of 5 over 3 all over -2/3. I have the y value, or the sine divided by cosine. Hey, sister. Okay. All right, so we got to simplify this thing, and this is tangent. So what I'm going to do is I'm going to flip him to the top. You keep flip, flip. So I keep this guy, I flip the division to multiplication, and I flip this to -3 over 2, and then I reduce. So my negatives are going to cancel out, and my 3's are going to cancel. So tangent will be the square root of 5 over 2 is what he will be, right? Because the 3's have canceled. And then cotangent is the flip of that, so 2 over the square root of 5. And that's how I find those values, okay? Sine is the y coordinate, cosine is the x coordinate, and then you just flip them and do all of the fancy things to find anything else, okay? So I can do that as well for all of my unit circle stuff. Like I could say, so cosine is this guy. Cosine of 120, whatever that is, right, is -1/2. Secant is what goes with cosine. It's the flip of that. So I could find secant of 120, which would be the flip of those. So -2 over 1 would be secant, right? I can use that information to find any of the 6 trig functions for everything on the unit circle. They give me sine and cosine of every single one. I can use that to find all 6 of them, okay? So let's do that right now, A and B, and then maybe we'll stop. That's might be all that I give to you today, okay? So the 6 trig functions for the real number t. 5 pi over 3. Okay, if you're struggling to find these on the unit circle, 5 over 3 is 1 2/3, okay? Now 1 pi lives over here. Like that's 1 pi. This is a half of a pi, this is 0 pi. 2 pi would be all the way around. So 1 2/3 pi is going to be beyond 180 degrees if you're trying to find where it is. 5 pi over 3 is this guy right here. Hey, look at that. We already talked about him. Okay, so I'm going to write down the coordinates for 5 pi over 3, and he is 1/2, negative square root of 3 over 2. Those are the coordinates, sister. Those are the coordinates that they use for 5 pi over 3, okay? So now I'm going to take those and I'm going to put those into the 6 trig functions. Sine, cosine, tangent, and then we've got cosecant, secant, and cotangent of t. Okay, and we're just going to put those guys into where they go. Okay, the sine value is going to be the y coordinates, so negative square root of 3 over 2. If I find the sine value, sine of 5 pi over 3 is going to be negative square root of 3 over 2. That's what he is. Okay, cosine is this 1/2. And now I'm going to do everything in relationship to those two guys. So if I flip them, sine flipped is going to be negative 2 over the square root of 3. If I flip cosine, it'll be 2 over 1, or you can put just 2 if you want, okay? Tangent's the one I really have to work a little bit for. If I take the y value, or the sine, divided by the cosine, I'm going to flip him to the top. Like keep flip flip. If you're dividing by a fraction, you multiply by the reciprocal, and then my 2's will cancel. So he will be just negative square root of 3 over 1, or just negative square root of 3, okay? I'm going to write him as negative square root of 3 over 1 to be able to flip him, okay? If I flip him, he's negative 1 over the square root of 3. That's what cotangent will be, okay? And that's how he works. All right, let's do B, and then we'll stop. Negative 5 pi over 4. Oh, man. Oh, man. Okay, negative 5 pi over 4. All right, if we look for positive 5 pi over 4, let me get rid of my stuff up here. Sister, what's the matter? Here, you go down for a minute. We're gonna yell and scream here pretty soon. Okay, 5 pi over 4 is, let's see, where is he? 5 pi over 4 is right here, okay? And 5 pi over 4 would be like this guy all the way around, okay? He would be 225 degrees, but we want negative 5 pi over 4. So what I'm going to do is I'm going to start here, and I'm going to go this way, and I'm going to go exactly the same amount. So this is a little over half of a circle. It's like 180 degrees plus another 45 degrees. So if I want negative, I'm going to go 180 degrees plus another 45 degrees. This right here at 135, that's the same thing as negative 5 pi over 4, or negative 225 degrees. It's just going back the opposite direction. So 225 is positive this way. Whoop. Negative would be the same, but in going clockwise, okay? Instead of counterclockwise. So hopefully that made sense to you. The negative square root of 2 over 2 and positive square root of 2 over 2, that is the coordinate for him. So negative square root of 2 over 2, comma, positive square root of 2 over 2. Okay, that is that. All right, so if we're doing sine of t, cosine of t. By the way, the reason why I put t in there is so I don't have to write 5 pi over 4 every time. This is like saying sine of negative 5 pi over 4, right? I just put t there instead so I don't have to write 5 pi over 4 every time. Tangent of t, cosecant of t, because that goes with sine. I put them in order. Secant of t goes with cosine, and then cotangent goes with tangent. Okay. All right. So sine is the y coordinate, so that is the square root of 2 over 2. Okay. Cosine is the x coordinate, so that's negative square root of 2 over 2. And then tangent, let's flip them. Let's flip them first, okay? So if I flip the square root of 2 over 2, that's 2 over the square root of 2, okay? Secant would be negative 2 over the square root of 2, okay? You can rationalize if you want to, if you know how to do that already, but we're going to wait and we'll rationalize like come next time, okay? Tangent, I do the y coordinate over the x coordinate, or the sine value over the cosine value. So this one's going to be really fancy. Square root of 2 over 2 over negative square root of 2 over 2. Okay, we keep flip. So I'm going to multiply by the reciprocal of this, negative 2 over the square root of 2. And look at this fancy business. The 2's are going to cancel. The square root of 2's are going to cancel. What the heck? What happens if everything cancels? Well, it cancels that, and it's going to reduce to be 1, right? Like it reduces and it becomes 1, except this negative didn't cancel. So tangent is negative 1. Okay, negative 1 as a fraction is negative 1 over 1. So cotangent, if I flip that, will again be negative 1 over 1, or just negative 1. So negative 1 is the reciprocal of himself. Okay, that was a lot to do. But anyway, hopefully that made sense. And that's how you interpret these numbers on the unit circle. It's trying to make shortcuts so that you don't have to use your calculator every time, kind of thing. Okay, so we'll get into more later on, but that is that. There's so much more to teach you about the unit circle. I could go on forever, but I'll spare you today. Okay? Try to get through some of those questions at the very beginning. You probably could be able to do like 16, maybe 22. I don't know for sure. But try to do as much as you can in the amount of time that you have left. Okay? We'll see you tomorrow.